Hello, everybody. Welcome.
Hello and welcome. Yeah, thank you for attending such a beautiful crowd, seeing some familiar faces looking right at me. Very happy to be here. So my name is Rodrigo. I've been with Gradle for about 10 years. And you might know me from such hits as the Gradle Kotlin DSL and the Gradle configuration cache. I'm here with my friend Alex. So Alex.
Yeah, I've been with Gradle for a little short while, but I'm working with Rodrigo on scalability aspects of the build tool and as a lead for Isolated Projects initiative. And a little bit of history about the build tool, actually. Our team is long there, more than 15 years of exciting features and updates, and it wouldn't be possible without a company behind that, company called Gradle that's been evolving and shipping all these nice features for you. And more recently, it wouldn't be possible with our commercial product called Develocity that integrates with the build tools and with Gradle or other build tools, accelerating them and giving you ways to observe and troubleshoot whatever happens in your build. And let's start with a quick shout out. Who has to wait for more than an hour on their CI to build the thing?
Oh my God, you should talk to us. Talk to us. Like that's, yeah.
Yeah, if you go a little more local, do you need to experience 10 or more minutes of wait when you run things locally, build your Android app? Well, quite some hands still, yeah, definitely you're in the right room.
Yeah, so why that's important, right? So why build time is important? Build time is important because not only the time we wait for a build, right, and the resources it takes away from us, but also the psychological effect, right, it has on our productivity. So there are like these time scales of psychological flow, right? So if something takes longer than a minute, right, you already start planning for it. You're gonna, I'm gonna bring my practice pad, gonna do some drills. That's what I'm gonna do, right? It's gonna take 1 minute. If it's something that takes maybe 10 seconds or more, your attention will start to drift and you suffer from context switch as well, right? So if it's 1 second, that's where we want to be, right, in that seamless state of flow. And if it's less than 1 second, then you feel like it's like magic, right? I'm the king of my domain. And that's what we want, right? As the Gradle build tool developers, we want you to be in that state. We want to build happiness. We want happy developers, right? Because productive developers are happy developers.
Exactly. Well, staying in the flow definitely makes me happy as a developer. Talking to my friends in the industry, everybody agrees with that. But of course, there are more hurdles than just getting to the flow state. Building software is hard in its nature. There's no way of getting around that. And we should acknowledge this. It's not something we should take for granted. But also, while it is hard and complex, we still need to make the changes. We still need to ship the features, fix the bugs, and proceed and improve our products. And at Gradle, we try to develop principles to build the build tool for you so that you can overcome those challenges. The first challenge is to make it simple to express what actually do you want to build and be able to change your build as easily understanding it. And we have a running experiment related to a similar announcement by other companies that we are currently doing. It's called Declarative Gradle, and we also believe that your build file can be as simple as that. But of course, in the real world, we understand that every application you build is going to be unique. That's its value. You cannot define it with a single line of config. So you're going to end up introducing more things you want to configure. And we still think that we can keep it more familiar to the experience of Gradle today while giving you much better tooling. So if you're interested in that, I encourage you to check out Declarative Gradle today. But in this talk, we're going to be talking about the way to make changes and to stay in that flow that Rodrigo mentioned that really improves the developer productivity and happiness in its way. And when it comes to the build tool, well, the build tool, of course, helps you to do the things you're doing, but sometimes, probably you agree with me, it could get in the way or it feels like it. And one of the things we're really looking forward towards and using as our guiding principles is to understand that changes we make are not equal. And the changes that are simple should be shown by the build tool, the results that you run should be also fast. But there are sometimes changes that affect the whole product, right? So it's not reasonable to expect that these changes will be fast. But when it comes to staying in the flow, this is what's most important. The things you do the most often, running tests, deploying app to the emulator, that should be fast. And this is what we're going to be talking about, which is commonly referred to as an inner developer loop, when you stay in the flow and you achieve your results. So how does it actually look with Gradle? So that we are all on the same page, let's get a quick primer. So when you run a Gradle command, say assemble debug, Gradle always does the following things. It does them in order to make sure you get reliable results regardless of what happened, right? You might not even notice, but say your environment variables have changed. So Gradle needs to make sure it takes everything into account to produce exactly the result that you need, staying reliable. And so the three phases have always been initialization, configuration, and execution. Quickly, let's go over them so we are on the same page there as well. So initialization looks at your project and tries to even understand what's the structure of it. Sometimes it would run init scripts and things like that. As a result of initialization, the project structure is there, so we understand the way the project is laid out on disk, what projects are there, and what type they are. When it comes to configuration phase, of course, in Gradle terms, those are called projects, and they're getting configured, running their individual build scripts. When Gradle does this, it discovers all the tasks it could run for the user. And then it combines that with a request that you ask it to do, for instance, assemble debug, and figures out exactly everything else it needs to actually perform and run to give you the final result, say in this case, an APK. Of course, this is a conceptual picture. When we talk about optimizing and improving our developer loops, we want to optimize the thing that's the longest. And historically, it's been execution, right? Running the tasks, that's actual work that's happening. It needs to be done, invoking the compiler, running those tests, what have you. And the way we approached it historically and continue to approach is through two different paradigms of work avoidance and parallelism. Work avoidance is, as you might guess, skipping the work that doesn't need to be redone, especially when you're staying in the iteration, think caching. And parallelism, obviously, using our more powerful machines today to run things concurrently in parallel when they are not dependent on each other. And we've been shipping features in that regard for years, right? Local build history, parallel downloads, running concurrency inside the task with Worker API, many things. But of course, yeah, and we definitely feel like we succeeded. And if you still find your execution phase long, definitely check out those features, right? But then, of course, industry moves on. What we observe the most is that projects get bigger and bigger and bigger, and there is no stopping that. And what that leads to is, well, now configuration phase is significant, and sometimes it could even be larger than the execution phase, given that the latter is pretty optimized. So, of course, we want to now make that better, again, to shrink back that developer loop that you're experiencing so that even if you work on a big project, you don't suffer from that unproportional overhead. And we are going to do that applying the same principles, work avoidance and parallelism. And this is where configuration cache comes in as a feature that builds on both to deliver that these fast developer loops for you. And so how does configuration cache actually work? Real quick. You can quickly enable it on the command line with a flag. And what it does is already what we've seen, right? So the configuration phase in its entirety, you can think of it as a function that takes the project structure and produces the graph of tasks to run. It could be a work graph containing more complicated things like artifact transforms that are common in the Android world, for instance. But of course, we want it to be a pure function. So again, we can have reliable results. So in this case, we need to mix in more inputs to that function, which we call build configuration inputs, which include things you might expect like system properties, environment variables, what have you, or anything else you touch during configuration that might affect the result. And so once that's in place, and we run it once, Configuration cache stores the result because it knows all the inputs, and the next time you run the same thing, well, we just skip all the work previously, so that's work avoidance in action, giving you amazing results. And we go directly to the execution, and every time we redo the same thing, right? When configuration doesn't change, say when you run the test, you're gonna keep on getting those hits, staying in the flow. And that's what's important. You don't have to take our word for that. We've been working with partners across the industry, and some of them share very exciting results applying configuration cache at scale, sometimes at really large scale. So for instance, Block shared with us that they save 4 years of engineering time annually just by adopting configuration cache, and they were one of the really early adopters of the technology. So a little bit of history. We didn't get there in one day, of course. This is a big feature, and the way we work is we try to give the features to you as early as possible, also to get the feedback, but for some early adopters that are ready to jump on and try it out, it would be already available rather than us holding it. So configuration cache was actually introduced way back in Gradle 6.6 as an experimental feature. Then over time, we worked on it, getting your feedback, and making it stable eventually in Gradle 8.1. And more recently, in the line of 8.x releases, we've been polishing it really, adding more and more updates, increasing stability to actually make it a preferred mode of execution in Gradle 9.0. I skipped over this part almost, but these are almost 2 years of continuous improvements that we've been putting out. So let's take a quick look. What are those exactly? One of the things you definitely would encounter when you adopt configuration cache is the report. It's a comprehensive report. You can view it in the browser whenever you run your build and there are configuration cache problems. It gives you an overview of all the problems, or the most of the problems that appeared there, but also gives you much more information. Of course, this is a lot of dense material. We're not expected to look at everything, but it has everything you need. For instance, it would tell you exactly why you didn't get that cache hit right now. Oh, that's because somebody touched the build logic. Maybe you checked it out from the remote, or you did it yourself, for instance. So you understand what's the reason, say, for the wait and breaking your flow. We've been working on improving the usability of that report significantly over recent time. For instance, making stack traces much prettier, extracting exactly the user line of code that produced that error so you can navigate directly to that and fix the issue right there. And there's more things, like it would list incompatible tasks that you mark them and you want to return to them, but they could be a reason why you're not getting cache hit as well. And one of the other things that I already mentioned is this build configuration inputs. And the report also gives you an overview exactly what goes into those inputs. And that's important because you want to keep that set of inputs as small as possible in order to get cache hits as often as possible. And in the line of reliability, we've been improving more ways we detect the way, say, your build has been touching state, reading files from disk that you might not even knew that it affects the results of configuration, but it could have. But we are really committed to reliability, and this is why it's an important topic for us. And of course,
Alex, can I stop you right there? I feel particularly passionate about that part. I think I should be talking, having implemented myself, you know, the feeling like I made fire.
Okay.
Kind of thing. Yeah. So, of course, it's not only about like user improvements, usability improvements and reliability, but it's also about optimization. So we work a lot on making sure these configuration cache entries are as small as possible. So we did a lot of work on data deduplication. That means like all those strings that are stored over and over, many objects, right? If you are familiar with the Gradle object model, you know about these attributes and other types of objects. They're like these immutable pieces of information. They're stored over and over in different projects. So we can actually store them in a single place. So we get a lot of bang for that buck, deduplicating. So here you can see the progress we made from 8.9 to the latest Gradle version release in the data sizes, right? That's for the Gradle build itself. And again, you don't have to take our word for it. So here we have Aurimaz from the Google Android X team. And this is proof that Aurimaz also says good things about Gradle. So I'm glad to see that. Also sharing his testimony on the fact that we made this improvement available to builds. And data deduplication not only gets you, smaller file size entries, but of course, it also improves performance. So again, here's what a configuration cache miss, so that the work, like the build time, related to the work that Gradle has to do when there's no configuration cache entry available, or the configuration cache entry has expired for any reason, compared to the latest version, right? So you can see we're getting really in that sweet spot for the configuration cache miss, where you're staying in the flow. And again, this is with the Gradle build itself. So the configuration cache, like Alex explained, is a lot about like avoiding work, but it's not only about avoiding work. So there's a lot of parallelism that we could also enable in Gradle because we now have the configuration cache. And the first thing we did was that now we could make all the tasks in your build run in parallel, even when they are in the same project. So historically, you might know that Gradle has this -- parallel option that allows you to run your tasks in parallel when you run the builds. But those are only executed in parallel when they're from different projects. So for instance, when you have 2 tasks in the same project, only one of them will run at a single time. But with the configuration cache, because we control, like Gradle controls, the loading of the data, Gradle can better isolate the tasks and make it safe to run them in parallel. So that's what we get from here. And not only that, but in a recent release, we also enable parallelism in the configuration cache implementation itself. So the way Gradle lays out the files in disk for the cache allows it now to load pieces, like the fragments of the work graph in parallel, and assemble them, so making for a much faster, cache hit experience. And all those 2 benefits you get for free, like they are transparent benefits that you get just by enabling the configuration cache. There's another aspect to parallelism, right? So I just said, okay, Gradle loads the configuration cache in parallel, so why not only also store it in parallel, right? Well, I could, talk all day about the joys of shared mutable state concurrency, right? And you know what I mean? He knows what I mean. So, yeah. So it's complicated. So because of that, we're making this an incubating feature for now. So you actually have to enable it explicitly. So what that means is that you might see problems when you enable this, because Gradle doesn't constrain the parallel of execution of your plugin code, of your build logic code. So for instance, if you have code that shares state in a way that Gradle cannot see, you might get in trouble. But of course, there's a lot of plugins and things are evolving fast. So once we have parallel store, what we get is that not only we can store the files in parallel, but also dependency resolution can run in parallel. So, and that was one of the biggest roadblocks for some of the largest builds and teams with the largest builds adopting the configuration cache, because dependency resolution might need to request files from the network, right? So it has downloads. So imagine doing all those downloads and waits serially. It really imposes a big penalty for the configuration cache misses, right? It's not moving. Okay, thank you. Yeah, so what does that give us, right? So here we have an Android application. So the first message here is yes, AGP, the Android Gradle plugin, and also the Kotlin plugin are compatible with parallel configuration cache. So in this build, we can see when you don't have the configuration cache enabled, this is just old, what we call the vintage mode of Gradle. And you can see it's actually faster than a configuration cache miss. And that's because with the configuration cache, you have these dependency resolutions processes running sequentially during this configuration phase, but also you have the overhead of storing, all these new files to disk. And with parallel CC, you can see that we basically get to about the same ballpark as before, so the overhead is gone. But more importantly, the difference would be even more dramatic if I was showing like charts of like builds that have to download. So these are builds that already downloaded their dependencies, right? Otherwise, it would be just off scale. So, okay, so it's all great, right? So how you go about reaping those benefits for yourselves, right? So how do you get to adopt the configuration cache? So the first thing is just to, tip into the water, like get your feet wet, run maybe a simple task from your build with the configuration cache. So try help. And once you do that, Gradle will tell you if your build is compatible or not, right? You get a report, like Alex showed before, telling you about all the problems, all the incompatibilities between your build and this feature. So why there are incompatibilities? Because Gradle has to store this work graph in disks, so it needs to understand the structure of the, the data, the objects you have reachable from your tasks. So that's why. Usually it works well, but we have, when it doesn't, the configuration cache have links to recipes that will guide you into fixing those issues. So our advice is to fix first those problems coming from the configuration phase, because with the configuration cache, you might also get a few problems coming from tasks during the execution phase. The reason is we are transitioning to better APIs that are compatible, and so if a task uses an incompatible API, that will be flagged as a problem. And once you have the configuration phase problems figured out, you can decide if those tasks that are remaining there are worth fixing, right? Because they are like frequently run and you need them as part of your inner developer loops. Or maybe you realize, okay, maybe this task is not really critical. So I can just say, okay, for now, I'm not going to invest on this particular task, and I can mark the task not compatible with configuration cache. So after you have gone through this process, iterated through, now it's the time for you to commit, right, and enable the configuration cache permanently in your Gradle properties file. So that way, any new incompatibilities, if any new code will be checked automatically for compatibility with the configuration cache, and you won't regress. So what is the expectation we can set here? Well, as I said, the ecosystem plugins for Java, Kotlin, Android are all compatible with the configuration cache. So you can adopt it today. We're making all the Gradle core plugins work with the configuration cache in Gradle 9. We still today have some plugins that are not working with the configuration cache, like Maven Publish. And we know that the biggest hurdle today is that many community plugins, some of the top most popular plugins, right, even, are not compatible. Many of those are. And I'll be talking more about that in the future. So after you have adopted with these expectations, now it's time to work on improving your configuration cache hit rates, right? So you want really to be in that happy path where the configuration cache can really just load the work graph straight from disk. So the first thing you need to do is to make sure you're using the latest available tooling, like the latest AGP, the latest Kotlin plugin, latest Gradle version. We work together with Gradle, with Google and JetBrains to make sure you have a great experience with the configuration cache, and they make sure their plugins are always compatible and always delivering improvements to configuration cache hit rates. So the next thing you want to do is you want to keep the set of these build configuration inputs that Alex talked about in the beginning, that you find in the report, to the minimum set that makes sense. So it makes sense to, from time to time, take a look at the report, see if there's anything that stands out. For instance, in this example, we can see a bunch of environment variables, right? So why these environment variables are part of my configuration input, right? Why does Gradle care about those environment variables? Well, it turns out there's some piece of build logic that is actually accessing one of those environment variables at configuration time. So there are different situations like this, or maybe it's a system property, or maybe it's a file that is being accessed, a configuration file somewhere. So we have different APIs in this case. You want to basically use the compatible API and just make sure that environment variable is accessed via a provider, which in Gradle is this abstraction for lazy values, values that can be delayed until execution. And once you do that, that environment variable will no longer affect your configuration cache hit rate, right? So after that, you want to make sure that you are measuring, right? And you are tracking your progress. And the way you do that, or you can do that, is by using develocity with the integration we ship for Grafana boards and Builder dashboards, where you can basically, from the data that develocity captures from Gradle, track like the top most reasons for cache invalidations across your whole company. How many cache hits you're getting, how much time you're saving, etc. Right? And after you have done all that, so what can you expect?
Wait. I'm very passionate about this part. Can I?
Okay.
Thank you. Right, we talked about configuration cache and the way we got there, the way you can adopt it, and the benefits that it brings. But what is the next chapter in the scalability of Gradle and the next chapter in the improved experience of your developer loops? Well, I'm happy to say I think it is isolated projects. Well, isolated projects is another feature of Gradle that we are working on. It is on par to configuration cache, and it indeed improves things the way we see it. Let's take a look exactly what that means, right, if you didn't hear about it before. So we know that the configuration phase configures the projects, discovers the tasks, builds the work graph. But, and we've talked about different ways we can use parallelism to speed things up, right? And we've made tasks parallel, made them run parallel within projects. Then we made the load of configuration cache parallel as well, thanks to the isolation, since it goes through the storage in the disk. You can even make the store parallel, even though you need to opt in. But we didn't talk about running project configuration in parallel. And that there is another reason for that. Well, there is a reason for that. And it's kind of similar to the joys of, shared mutable state concurrency, because it's sort of the next layer where Gradle historically allowed you to do anything with your project. That is the strength of the build tool that comes with the flexibility to allow you to do that. But we recognize for some use cases, you don't really need that flexibility. And if we could say, well, here's a trade-off, you give us a piece of that flexibility back, but we can make things significantly faster, like next level faster, basically. You can already try isolated projects, although it's in really early stage. But as you might have guessed, what it actually does is it makes sure that projects do not reach out into their shared mutable state, or one project does not touch a shared mutable state of another project. And in this sense, this feature is also safe, it's guarded for you. You wouldn't be able to make a mistake when you try out isolated projects, because you would be notified about any violation that could essentially corrupt the reliability of your results if some concurrency is involved. And this is the way we want to build most features in Gradle, giving you this guidance, the reporting that supports you on the path to adoption. And, well, once the projects are isolated, once we know there is nothing funky going on, the simplest thing we could do, and we intend to do, is to actually run all of that configuration in parallel, which quite obviously speeds things up significantly, especially if you have many projects, if your build is large. As I mentioned, this is the next chapter of the scalability, and it builds on top of configuration cache, meaning that you still need to adopt configuration cache, which we saw already comes with the benefits, to try out isolated projects, because more rules are in place. But running project configuration in parallel is only the first step towards faster developer loops in more scenarios. Once things are isolated and we know that this project has not changed this project, not the whole configuration, we can skip configuring that project by itself and only reconfigure the project that you actually touched, if you touched any. And of course, since it integrates together with configuration cache, if you didn't touch anything, we'll skip all the work and you get a cache hit for CC that still keeps you in that loop close to a couple of seconds build time. But the result of the running with isolated projects is the same, right? You get the work graph with the same tasks, and then we run them in parallel. But running tasks is not the only thing that the Gradle build tool does. And possibly you don't know this. I hope you do. When you open your project in the IDE, a Gradle project, IntelliJ IDEA communicates with Gradle. It syncs the state of the project the way Gradle sees it and shows it to you in all the UIs, keeping it consistent. That's, again, another part of reliability, so that you as a developer know exactly what you're dealing with, even if you change anything related to a build. So working with a project in the IDE gives you the same build results, basically, as, for instance, on CI. So when you open the project in IntelliJ, it syncs the project by talking to Gradle through a special API called Tooling API, and it asks it exactly about the structure of the project and about the tasks. So that means it requires Gradle to configure all the project. So we're sort of back to the same predicament that sometimes sync could be slow, and we understand today this might be the main reason why sync could be slow, is because we have to reconfigure everything. There was no way for us before to ensure things are not interfering with each other. But isolated projects give us this guarantee. And this is one of the first things we want to address with isolated projects, is actually make syncs much faster and run project configuration in parallel. And of course, it doesn't only extend to IntelliJ IDEA, the same thing would apply to isolated projects. And as Rodrigo mentioned, we keep tight collaboration with JetBrains and Android folks to make sure this integration is as smooth as possible. And with these possibilities of increased parallelism and concurrency, we're also working not only to make the Gradle part faster, but look across the stack and find the ways to optimize the whole process so that you get your sync done much faster than before. Isolated projects are pre-alpha. They are pre-alpha because we decided to call them that, and we call them alpha when we feel like it. But they are already pretty exciting. Our early measurement tell us that when you get a cache miss with isolated projects, even when you have nothing in the cache, they are already faster than the vintage mode. Why is it important? Well, configuration cache, as Rodrigo mentioned, comes with some overhead that is inescapable because we do the isolation through serialization. And parallel CC already takes back some of the time, right, some of that overhead to make things faster, and that's what you already can use today. Isolated projects takes it to the next level, actually make the whole thing faster. So it does not matter anymore that you have this overhead when you get these benefits at scale, and the larger your project is, the larger the benefits would be. And of course, since IP builds on top of configuration cache, when you get a cache hit, you get the same fast result as with configuration cache. So that makes it pretty exciting. And I've been talking about isolated projects, their current state and their future a little bit, but what actually comes next? Would you care to share?
Yes. So I'd just like to set the expectations straight here. So We're definitely talking about the future when we talk about these benefits that isolated projects and some of the things I'm going to talk about here will give you, right? So today, we see benefits in projects like now in Android, Gradle, which are not particularly big. And the reason is isolated projects has been in this phase where we're making it correct and reliable, right? We haven't optimized, for example, memory consumption. So if you have a very large project, running things in parallel can actually compound memory usage, right? So you might actually see worse results if you are in the thousands of projects scale. And that's something, of course, we want to work on as soon as possible. So again, I'm talking about the future, right? So the best way to predict the future is to invent it. We're trying to do that, but we might get it wrong, right? So beware that some of these things might not be fully realized, but it's our best intention that this is the case. So immediately, we are working on configuration cache being the preferred mode in Gradle 9 that is soon to be released, Q3, early Q3 this year. So what is preferred mode, right? So first, we want to make like a strong statement, send a strong message to the community of plugin authors that this is the time to adopt, to migrate, to make sure you are compatible with the configuration cache, because we are making configuration cache the default mode in the next major. So that's the first thing, to eventually become the only mode that Gradle operates. So Gradle will start to actively nudging users, right, to adopt the configuration cache when it detects the conditions are potentially right. We make sure the Gradle core plugins that are currently not working with the configuration cache will seamlessly work with the configuration cache. And we're going to start removing incompatible APIs. So plugins that are relying on incompatible APIs will no longer work in Gradle 9. Right? And after Gradle 9, we'll continue to deprecate and remove these incompatible APIs. But more importantly, we're going to start a dedicated effort to push adoption across the community of plugins. We're going to start reaching out and making sure we give the support the community needs to make those plugins compatible with the configuration cache so all the users can start reaping the benefits. So we're going to continue, right, improving hit rates. We're going to integrate these problems, the report in more places, so they are more easily navigable from IDEs, from dev velocity. So you also have more ways to track data. And with Alex leading the initiative, we're going to ship isolated projects to early adopters.
Yeah, maybe a quick word about this as well. As I mentioned, one of the first things we want to address is making the sync faster. So working with the IDE vendors, bringing that experience to you right there. But of course, since it's early times, we are still working on some APIs, new APIs that are compatible with isolated projects, but also, harmonious or idiomatic with the rest of the Gradle. And while we're at this stage, some of the use cases, potentially popular use cases, are not yet covered. And this is why it's still not incubating. As soon as we are there, and we're going to reach out for your feedback and share with the community through all our channels, such as community Slack or potentially blog posts, to start getting your feedback once we feel it's ready.
Yeah. So I laid out a few of the things we're going to be doing. So what could you be doing to help, apart from what Alex says? Yes, you should start developing and iterating faster with Gradle if you're not. You should use the configuration cache today. You should try parallel configuration cache. If you are in this sweet spot, it might actually help you quite a lot. And get ready for isolated projects. Thank you.